Can you hear me now? So the reason why I have to be on mic is not because you guys need to hear me, because y'all know I talk loud, but because we live stream this for people who can't be here in person because they live far away. And we actually even take questions from people who live far away at the end. So it's kind of cool because we're here at CBSI that we can do all this fun stuff. So some of you are new. Hopefully you know that there's pizza outside you can have. There are drinks. I give out raffle tickets because O'Reilly is a sponsor, and we usually have books to raffle off, and tonight we have some other fabulous goodies. Percona is one of our sponsors. They pay for the pizza. And we love Percona, but tonight they don't have a Percona person here. We usually do. They're really great. If you don't know Percona, you should check them out. You probably read their high-performance MySQL blogs, whether you know it or not, and they're really great, and we love that they sponsor our pizza. Generally at this time, we open it up for announcements, and since CBSI gives us this space, we let them do the first announcements.
Woohoo! Yay for us.
I have a microphone.
Oh.
So anyway, so CBSI, we're hiring almost all of our sites, GameSpot and Metacritic, CBS.com, CBS News, CBS Sports, CNET.com, Money Watch, Market Watch, I forget what our new site is. But anyway, we have a lot of sites. But so we're hiring for a lot of different positions all the way up and down the chain, both in tech and kind of on the more business side. So if you know of anyone or are looking, there's several flyers in the back of the room. Let us know. You already mentioned O'Reilly and Percona, so we're covered there. Did want to mention a couple other events coming up on September 27th. Joe Stump from Simple Geo, they're going to be out here at the PHP meetup. It's Thursday the 27th here. Talking all about geolocation, kind of the latest buzz. October 5th, the Web Performance meetup is also going to be here. That's going to be Nicole Sullivan. She's going to be talking about CSS performance. It's the other side of performance than probably most of us deal with, but that most users are impacted by. I mean, it's easy for us to get our pages under a second, but if the front end takes 6 seconds, what we did doesn't really matter. And then tentatively on October 28th, there's going to be another big cross meetup tech event on jQuery. Tentatively scheduled for Thursday, October 28th, but that'll be all about jQuery and then how CSS3 and HTML5 will be changing the way in which JavaScript, what you need to do with it, and all that kind of fun stuff. Tentatively October 28th. There'll be an announcement when it's finalized. We're waiting to hear for sure from the speakers. As Aaron mentioned, we have a bunch of books from O'Reilly, but it would be great to get feedback as to what books you all want, because for the most part, I just kind of browse through what looks interesting to me or what Aaron asked me to get, but this is all about you all, so let us know what you want, and we'll try to get those.
Get the new replication book's quite good.
Which one?
I think it's MySQL, MySQL Scalability or MySQL. It's just.
Oh, the one that you have in your bag?
There's a new O'Reilly book that just came out in the last 2 months, and I got a reviewer's copy. It's quite a good read, so yeah. I would recommend that.
The high availability one?
Yes, it's high availability. Thank you.
It's the one in Aaron's bag. We'll raffle that one off later. But anyway, at this time, want to open up the floor if anybody has announcements.
I think we had one person.
Have at it.
Hi, I'm Evan from PHP.com. We're currently looking for PHP MySQL engineers. So if you'd like to talk to me or John here while we're here tonight, or you can go to gdgt.com/jobs, or send an email to jobs@gdgt.com. We'd love to have you if you're interested. We also do, actually, we brought a shirt here that'll be as part of the raffle. So feel free to get in on that.
Stickers in the back as well.
And there's decals too.
Yeah,
So,
stickers, all different colors. Thank you.
Not on.
Hey everybody, I'm Tim. I'm from Mixpanel. We're a real-time analytics company. We're looking for people to do Python and hardcore MySQL.
anybody's a DBA, you can see me, and this is San Mateo, and I have cars. So we're done? So I don't know about you all, but I'm
It's definitely not working.
It's not working?
No.
Sorry, I missed your... Is this one working? Okay. I have a big voice, so normally I don't need a mic. You know, I don't know about you all, but I read a lot of the Planet MySQL blogs. I follow a lot of the gurus. And I like to have speakers come here to talk to us. And so I hunt them down. And I'm sort of getting a reputation. First I started in Twitter. We got Craigslist Jeremy coming out here. I hunted down Giuseppe, but I went to him at the conference and cornered him and made him promise to come talk to us. With Ronald, he had this great post about this talk he was giving in Toronto, and I'm like, hey, how about that in San Francisco? So I twisted his arm, and it's just so exciting to have some of the people that are experts in the MySQL world be able to come here, because Oracle is close enough that when they come to Oracle, they can stop in and give a talk, and we have an opportunity to hear some of the fabulous gurus in our world. And so I'm really excited to have Ronald here. And so with not anything else I have to say, it's just welcome Ronald. Bye.
Thank you. I got to clap before I start, which is usually uncommon. So thank you for inviting me to come this evening. I'm actually here for meetings with Oracle today and tomorrow, and MySQL Sunday, a part of Oracle Open World. And Erin actually contacted me because I blogged about a presentation I'm giving in 2 weeks' time in Baltimore at Surge Scalability Conference, where I submitted a talk called Common MySQL Scalability Mistakes and How to Avoid Them. And between submitting that and between talking here, I decided that the talk wasn't quite the title I wanted to present, because it's sort of rather negative rather than positive. So tonight's actually more of a positive discussion about successful MySQL scalability. And I wanted to do this because there are certain principles that you can put in place in order, and it will lead you to a path of being able to successfully scale your applications. I've been doing work with databases for over 2 decades now. And a lot of what I'm going to talk about is not something that just belongs to MySQL or Web 2.0 or something that's a new rad sort of approach. They're good, solid principles that, unfortunately, most clients that I look at don't have in place. So it's really important that we go through tonight to find a clear, concise, and reproducible method of how to scale successfully. So it's going to be difficult for me to solve this problem in 1 hour. I will give you a money-back guarantee, however. So that's a good thing to have. But what I'm going to go through works and has been successfully implemented without any troubles. So what are some of the necessary principles that I'm going to talk about tonight? They're going to cover a certain number of areas I have there in terms of system architecture, data availability, and definitely best practices. And these can be applied from a startup up to a Fortune 500 company with thousands of servers. Unfortunately, most clients that I have seen fail to come close to successfully implementing things. The closest I've had is my largest client, which was eBay. So quite often it takes time and takes years to actually progress into doing things successfully. But hopefully tonight you will learn how to avoid that. My goal is not to just give you the fish. The goal tonight is to teach you how to fish. So therefore I'm doing myself out of a job. That's life. So get started. What's the most important thing for successful scalability? I wasn't going to ask question Q&A, but someone want to hack a guess?
Keep it simple.
That's actually a good principle to have, yes. No? Integrated monitoring and instrumentation. It's as simple as that. You need to have this available from the first time your systems become available. I would even propose that for servers that are actually initiated into your environment, even before they're configured as a database server or web server, they're enabled into your monitoring and alert system. And they should actually be failing until they're actually correctly configured. It's important that you actually put in place this first. It's often an afterthought with clients that don't have sufficient monitoring in place, and quite often you spend all your time chasing problems rather than having those problems be presented towards you. What's interesting is this is actually not an uncommon approach. It's a test-driven development approach at a server implementation layer. So for any of you that are using Agile development processes where you're like writing test cases or you're writing code that's testable, then the same principle applies here in terms of monitoring. This is a way for you to test and monitor your systems. And once implemented, if you actually do this when you first start, it becomes second nature and you'll wonder why you didn't have it in place when you started. So what I'll do is I'll give you a good example. Actual client, full production systems. You know, a small client just had a little disaster. And I asked them this question. How do you know when your server is not available or not accessible? And their response was, well, our customers will tell us. That's the wrong answer. Because, you know, if you value your business or you value your customers, then you need to know when something's happening beforehand. So the most important thing to start with is monitoring and alerting. These are basic principles. I'm not going to go into the details of what they are because you all should know what they are, but it's necessary for you to provide a collection of historical information that enables you to trend things that have happened on your servers. Generally, most monitoring systems provide graphical interfaces, so they're very visual, and that can provide a benefit for identifying trends when you could sort of go back and compare what things are going on. But it's rare to actually find an environment that's been correctly configured for monitoring. Quite often it's an afterthought and some servers aren't in place. And as I mentioned before, I advocate that you put this in the stack before you even start deploying software. I've had clients who do stress testing on their servers, on their applications, like 10 servers at a time in a stress test environment before they go into production, but they won't enable the monitoring until they're ready to deploy the server into production. How do they test their monitoring system? How do they know the monitoring system works? How do they know what thresholds to send on alerts? So it's really important that this becomes an integral part of the actual development lifecycle. And as a list here, you know, it provides historical information. It's definitely necessary. Doesn't exist in most environments. But the most limiting factor of monitoring is it's generally useless in a real-time environment. Because as a DBA, when you get that, you know, inevitable question, the website is slow, and you go, well, you sure it's the website or the database, and all those sort of things. Monitoring won't help you, and that's because it suffers from a principle of sampling, and that sampling time is generally 1 minute or 5 minutes. And problems can happen in the space of seconds, and if you have 10,000, you know, threads per second across an array of servers, you can't wait 1 minute or 5 minutes for the server to be for you to be told the server has gone down. So, whilst this is essential for you to be able to do historical work and trending analysis, it's only halfway towards having integrated monitoring. So, as I have there, this is a reactive process. So, the simple solution to this is to have a dashboard. And a dashboard should be, keep it simple, which is the right principle. So, one page. Very simple traffic light scenario where red is error, yellow, amber is, hey, there's something not quite right, or green is okay. Condense as much information you can onto one page with key performance indicators, numbers that are important that relate to your servers. Are they up? What's their ping time? How long is the page load time? How many database connections have you got? How many are locked? How slow is replication? You put all those things on one page and you sample at a frequency which is fast enough that you can consider to know how the system is working on. And I come up with an equation of basically 0.1%. So, you know, for 1,000 requests, you're making one request. So that shouldn't be an overhead on your system. And if you can sample things at, you know, 1, 2, and 5 seconds, then you're actually having a view of your system much more closer and more respective of what's going on. I haven't actually found a product that does this. So I've implemented it for a client with my own code, and one day I'll open source that unless someone pays me to do it. But what you really want to do is with the dashboard, you want to identify what's important to you. So in the audience here, we have database administrators and we have developers and system architects. So it's important you know the metrics that you want there. But what if you are a business person? What if you want to know what, you know, how long the page is loading, or how many people do we have on our site right now, or how many people are making comments, or how many people are viewing a video? It's important that you have a dashboard that should be available internally. The CEO should be able to look at it. You know, you shouldn't have someone to come in and say, oh, the website is slow. Hopefully they'll come in and say, there's a red thing on this web server. You know, is that why the website is slow? It's a small but important educational lesson for people to move forward. The thing that you'll notice is that most successful large sites actually have internal dashboards and external dashboards, public dashboards. Twitter, Amazon Web Services, SmugMug are good examples where they have good dashboards and they show you the state of the services that are happening right now. Unfortunately, this also suffers from an economy of scale problem. You really want to keep it simple. You want to have one page which is initial triage so that you can help identify where a problem may be if someone asks you or if you're looking at it. But if you're a Facebook that has 6,000 database servers, it doesn't really work too well on one page. So it's important that you collapse down what information you want, maybe only error systems or maybe heat maps that can identify where your problems really are. So really should read my slides before I type. So this is a more proactive approach in terms of being able to know what's going on with your systems. The second component of this is instrumentation. It's very easy to monitor a system and to find out how long it took for the web page to load or how long it took for a database query to run. So in totality, you can use those pieces of information. But what's important sometimes is to know internally what's actually happening. So having instrumentation which is applicable to either the business, like orders per minute, or a certain portion of load time for certain chunks of information, is really necessary so that you can actually know what's going on in your server. As a DBA, the problem is that you're always trying to tune the systems to be more performant. And a lot of times when I'm employed to come in and do performance tuning, which is generally the tip of the iceberg, the first problem is just gathering information. And quite often people just don't know what's applicable to gather. So it's important that you put numbers and metrics in place that enable you to be more proactive in your roles to be able to find what's going on. Another thing that's important is that this doesn't require you to change code. You shouldn't have to reboot the server to change a parameter for a JDBC connection string. I've had clients where I wanted to say, I want to turn this tuning on. They have to build the entire application, deploy the entire application on the production server to change one variable in a connection string. So it's important that things are seamless. You know, whether you can enable it by an admin web page to say log extra information, or a parameter which is debug equals true to put output into the HTML file or something like that. It's something that, again, you should consider in terms of, even if you're a DBA, you should be encouraging developers to use this approach because it will help you. And sometimes it's hard to explain to them why. So again, this is a proactive approach to doing what's important for your scalability needs and sort of first identifying where issues are. And the reason why I say this is that the monitoring component and the instrumentation component, the dashboard component, combined enable you to be more proactive and to do preemptive analysis. Because the goal here is we want to make sure that our systems are highly available. Failure of that is if the system crashes or the system is non-responsive. So if you can address that issue before it happens, then you have a better chance of doing successful scalability. Let me give you two examples. As I said before, I advocate having statistics in your application to know, for example, what's important. I wouldn't advocate putting it on the main page, maybe embedded in the HTML, but not exactly presented. But it's a good example for this case. So this is the new Dig website, which I don't know if anyone's been trying to use and it doesn't work. Yes. I heard someone got fired over that too. So the question asked is this providing preemptive analysis of a problem with the system? This page took more than 5 seconds to load. So it kept the socket open on the web server, it backed up all the other connections that it had to do, and it put more load on the system probably than it needed to do. And that becomes a cascading effect. So what's important is that if you can be preemptive in what you're doing, you can overcome that problem, and you can come up with a screen like this. Who hasn't seen this before? Who hates seeing the screen? Be honest. Few people hate seeing the screen. You may hate seeing the screen, but it's actually a very good thing. Twitter failed whale is a good example of preemptive analysis. And if you ever see the screen, generally it happens very quickly. It happens in like sub-second response time. And what they do is that by looking at their monitoring and alerting and understanding the loads and the thresholds on their systems, they can actually preempt before they get to a point of failure. And yes, I agree, it's frustrating, and yes, it's a way to say it's more available and less available. And it's annoying, but generally it's quick and it resolves and it works okay. But it's quite good because what happens is queries to fail early. Users get an immediate response as to what's going on, a faster response time, and you're not putting extra load on your system into this cascading effect of problems. So what's important is that to do preemptive analysis, you need to know what your limits and thresholds are in the system. So you need the monitoring in place to determine that information. And you really want this because you don't want to put the database into a particular state where it's locked or it's frozen and you don't know, it hasn't crashed, but, can I log in? Should I kill it? Should I not kill it? All these situations lead you to put you in a recovery path. Most clients don't have a very good recovery path, so it's better to not get to that point. So successful scaling, Twitter has a couple of modes. One of them is the preemptive, they call the fail whale, which is a preemptive approach, and they have another concept which is called dark mode, and I'm not going to talk about that, but they're principles that you can apply in application development. So just wrapping up my first point, it's important that you have a couple of extra information if you want to be proactive with your clients. Have a status page that tells you what's happening on site if there's a problem. Have a public dashboard that people can know if services are up or down. Be proactive. Notify people of what's happening so that the users can feel like they're empowered in some way or important. And most importantly, don't put it on the server that you're running your production server on, because you really need to host it somewhere else. So the advice is find some entity, WordPress, Tumblr, some other organization that already has a large infrastructure, which is hopefully scalable and more highly redundant, that can at least tell users what's going on with the system. So, small introduction. Second most important point is to do successful scalability, you need to have a seamless, automated approach for installation of software. It sounds harder than what it actually is, but again, it comes down to having a principle in place of what you want to do. So this involves you being able to configure your server, install your server, deploy your server without human intervention. So you want to be able to take what you have and be able to deploy it not once, but not twice, but 10 times, 100 times, and really just, it's really something which doesn't have human hands involved. The line from the Oh Robot movie, which is like, no human hands are used from conception through to deployment of the robots, is really what you'd like here other than just powering up a server and putting it in the rack. So this isn't practical when you first start off in a website environment. It's not practical to invest the time to do this. It is practical for you to document what you do and to run it on the command line so that it actually is reproducible. And the second time that you run a server, you should be cutting and pasting. And you should be moving towards a process of being able to have servers that you can deploy more seamlessly. It's ideal for many environments, for disaster recovery, for testability, for new environments, and it's a process of involved with continual improvement. So let me give you another example, similar to my example in the first case. This is an existing real Fortune 100, Fortune 500 company here on the West Coast. Does someone want to point out to me what's wrong with their approach to scalability? Anybody? Yeah, more than one thing. So the issue here is it's not the lack of the full-time DBAs who don't have the skills to do this. It's really a lack of initiative. It's a lack of input, for, need for their ability to be able to make a system better, to make it more supported, to put quality in place. And trust me, you see something like that, and it's just really not what you want to be able to do for being successful. Because your job should be to solve hard problems, not to do mundane, repetitive tasks every day. Who would find it more challenging if you actually could, work on the new version of software to test it, or write a blog post, or attend a conference without the pager going off 10 times a day? So, I say this because, unfortunately, people don't get it. Who here doesn't use version control to manage? How many people are DBAs? Developers? A couple. What's everybody else? Hawkers? Free beer? Pizza? So, version control is essential. And everyone here who touches a computer, I guess you all write code somewhere, right? Who doesn't use version control? Put your hands up. Everyone uses version control. I don't need to be here. Okay.
Well, for code, but not for the
everything.
stuff.
Yeah.
not version control.
We'll talk a little bit more about config files in a minute, but it's important that you put stuff into version control. That's the scripts that you use, that you run, that you deploy, that you have on servers. Because it serves multiple purposes. One, it's an audit trail of what's happening with your systems. Two, it's a reproducible means of creating software for deployment. Software deployment should be read-only. You should be able to splat the software down and be done with it, with the exception of the config files, and we'll discuss that in a minute. And it's a necessary basis for you to be able to do any level of automation. You should be able to Have software that you can build, tag, release, and deploy in a seamless approach. And again, this process is based on actually having monitoring in place. So you should be monitoring this build process so that, if it fails, you can work on being able to deploy software. But just because you have a system that has monitoring in place and you've deployed it, and you've got a process to be able to copy up your code and ship it over to a server and untar it, it can be as simple as that. It's important that you have additional checks in place. One of them is a concept of a health check, and that's a series of very simple commands that audit, that give you okay, not okay, that you can run across your production systems even after they've been deployed, because configurations may have changed, other people may have installed software, and it's important to know that your systems are actually consistent with the specification that you have when you have 100 servers or 1,000 servers. And if you're going to roll out a new version of software, you want to have some way to verify the state of that by being able to run through a series of checks, 20, 30 points that go, is this configured as in the right directory? Is this not full? Is MySQL, automatically starting up on reboot? All these sorts of things are important for you to be able to know that your system can be automated and can be in a state that can actually move on. Aaron touched on configuration files, and this is a common problem when people start using version control, is they put the configuration files in the version control. And then when they deploy it, it overwrites the production configuration. You should never put configuration files into production. What you should do is put my.cnf.sample or .example into your deployment file. What you should have in place is a system to do configuration management of production config files. And there are several products out there, but that should be under a separate type of version control where really changes are actually checked in runtime systems, and you can start a new server and deploy a base configuration of production for 5.0 or 5.1 or 5.5, or you can restore the configuration of a particular server that you've actually had installed previously from a recovery perspective. And I'm going to start moving into some other reasons why there are certain principles in place to do successful scalability. And one of those is benchmarking. You need to be able to benchmark your systems. You need to be able to create your system from scratch, deploy your software, install it, and benchmark it, and see how it works. You need to have monitoring in place so that you know that that's actually running, it's getting better or worse between versions of software. So you can see that everything I'm talking about is building on important building blocks. The order is important. And then once you get to be proficient in deploying software, advanced techniques is you have a queuing system, a coordinator, a caretaker that manages the creation or management of servers in your environment. You have a queue that says, this cluster of servers, I need a few more read slaves, or I need a couple more web servers, or, this failover server is not working, so I have to configure a failover pair or something. And what's really ideal is that when people can put a box into the rack and turn it on, and it's smart enough to notify a coordinating node to say, I'm available, what do you want me to be? Okay, so you're not putting a machine in the system saying, you're a database server, you're a database slave. There may be certain hardware configurations, but having this process where the system will just manage this allows you to scale more infinitely. And this is important for people who are doing cloud computing, Facebook. I have 1 million users this week and 10 million users next week. You can't just keep doing things manually. You need to be proactive in being able to initiate up and down servers of what you want to do. The goal really is consistent and timely provisioning. So I don't know if you work in any organizations where you're deploying software here. Let's take CBS as an example. Someone says they want to create a new website to run on a television show that's coming out in 3 weeks' time. Do you have a system in place that you can provision hardware, deploy it, get it up and running?
I hope so.
Yeah. And unfortunately, there are small companies that are like grasping with, okay, we're bursting at the seams, when we get, another server or scalability issues, particularly like a Facebook application. But there are large organizations that have data centers of thousands of servers, and they still can't go through this process without, days, weeks, or months. So it's important that you can streamline as much as you can in the process without bureaucracy. Point 3. What did I say point 3 was going to be? Before my machine wouldn't boot. Disaster is inevitable. Of course, it applies to more than just the database, as when my laptop occurs. It applies to the fact that yesterday I lost my wallet on the plane. So it always happens. Again, let me start with something that's real that you can attach yourself with, an actual client. And I asked the question, have you ever performed a database backup recovery? And they say, no, why? Do you know that your daily backups copy your data at the point in time in night, and that everything that happens after that point in time is not recoverable? And the client didn't know this. This is someone who does a after-sales auditing system, and Ford is their largest customer. So you don't want Ford to lose $1 million sale, do you? So it's very important that you have in place a disaster recovery plan. Now, again, we're talking here about scalability, so you might be wondering, why am I ranting about monitoring or deployment or disaster recovery? It's because you need all of these as building blocks before you can even write code to be a DBA to support scalability. So a disaster recovery plan is necessary, and you have to go through having a documented disaster recovery plan, a tested recovery plan, a timed recovery plan, and a verified recovery plan. And I know I sound like a broken record, but I don't find any clients that have a successful disaster recovery process in place. Anyone want to admit that they have theirs perfect? No? No takers? Anyone awake out there? Wave hands. All right, okay, this is a test to wake everybody up. Who here is going to MySQL Sunday this week at Oracle Open World? Wow. Why is everyone else not going? Who would like to go to MySQL Sunday at Oracle Open World? There you go. Very good. Well, I've got some free passes, so come and see me later and we can take care of that. We will, but I wanted to wake everyone up so everyone's sleeping out there. So they think that nothing's happening. So I'm down one. But I wanted to highlight that even though you think you may have documented your disaster recovery plan, even though you may have tested it or you timed it, has it been verified from end to end? I see plenty of examples where people think they have something in place and it doesn't actually work. There are also people who've done a database recovery, but not end to end. They recover the database portion, but they don't make sure the web servers are turned off or the firewall rules are on so that people can't access the database so that you can verify it. Or there's issues in terms of okay, do I have to do extra checks before I gain access to users? I've seen a production environment with an IDDB disaster recovery recover 95% of the data in 5 minutes and then take an hour to do the last 5%. And if you don't know why and you're expecting it's going to take 10 minutes and you're told management it's going to take 10 minutes and they go, okay, that's fine, we can accept losing 300 orders in 10 minutes, but then it takes an hour and 10 minutes, then it's a little bit more complicated. So it's really important that you actually have this in place. And this is necessary as we start moving forward in further principles of scalability. There's also nothing worse than having a disaster recovery process in place that takes 10 minutes because you tested it on a production system that had no data or had no load. Don't laugh, this actually happens. There are people that do this. And then they report to management that our system is recoverable, or they report to their internal clients, customers. I have clients that generate hundreds of millions of dollars in revenue on systems that aren't correctly configured to support disaster. What happens if that was unavailable for 24 hours? And it affects tens, 100,000s of users. So the goal here is you need to know and you need to prepare for a disaster. You need to make sure that you're confident in being able to do that, and that comes from having empirical evidence and a track record of doing it. And here's another interesting thought. People are very good at scaling their service. People say, oh, there's a problem. How do I scale my system? You can add more service to it, or you improve something, or you reduce functionality. But very few people are as confident about the disaster recovery process as they are about scalability. And if you don't get disaster recovery right, you may be lucky, you may survive, but you may not. The best case I've had is a $100 million company, and it was a $100 million company because they sold within 6 months after the disaster. And they had a very expensive SAN, and an engineer from the company was working on the SAN and did something they shouldn't have done and dropped 160 mount points. Trashed 60 database servers. Took their website offline for 3 days. So you need to make sure that is important. And that's why I was involved with the DBA recovering this, that I knew who was wanting some sane person to talk to them. And their business, they almost went out of business because they didn't prepare for disaster. So I warn you. I encourage you. So this is a little sort of like, I said sidebar. This is just an example for you to think about it. What does your website look like when it's down? Does everyone know? Have you removed network connectivity to the database to see what happens? Does it look like this? A Google website? Does it look like this? I don't know where that was. I think it was like something monkey, monkey or something, some new startup. Does it look like this? Mozilla in the Firefox 3.0 download day. Everyone remember that? They'll download Firefox. It should have looked a little bit like that, but it should have been more proactive. Or it should have something in there that at least encourages people to think about what's going on. I'm not going to tell you here what to do, but it's important to actually know what does your website actually look like when it's unavailable. You might want to add that to your list of things to do. So what I've done is I've talked about a few principles, and they're building blocks on what we're going to talk about next, but they're essential building blocks so that you can actually scale more successfully. And so they're really in terms of architecture, planning, things that I don't think anyone in the audience would say, I didn't know about, I shouldn't be monitoring my systems, or shouldn't be checking in code, or I shouldn't make sure I have backups in place. You all know that, but you need to practice it. This is in this case, 6-point plan or 7-point plan for successful scalability. When we start talking about, we haven't done any coding yet. There's no coding. The system's just making sure that it works before we even let those developers mess up our nice, pristine environments. The most important thing to have in place for development is an API layer. That is for those people here in the room that are older than the people who just came out of college or started reading a book. MVC model where you segment the processing and the database and the view and the controller and the data separately so that you can work on what you want to do. People don't think this is important, but I can guarantee you it will save you bucket loads of time later if you just do it right from the start. You may consider it's unnecessary later. You may consider it's additional latency in the process. You may consider it's additional servers. But code quality and scalability will be better over time. So, again, customer examples really help. So here's a customer example of someone who had an API. They also had their own website doing code, and they also had batch processes which would do similar things. 3 separate code paths for one piece of business functionality. So the problem with this approach is that at some point in time, something is going to get inconsistent. Either a step is going to be missed in terms of migration. That could lead to database inconsistency. It could lead to database corruption. It could lead to invalid data. The solution is to move to one code path. And if you actually develop your system, which means to access data, you have to go through an API. That's a specification that defines the inputs and outputs that you have in the system. That's the minimum requirements. The second layer of requirements for an API, which is necessary for scalability, is that you have metrics for growth, volume, and metrics for latency. So they're necessary so that not only this is what the input is, I give you a user ID and I call this API, and you give me back their name and their email address. That's the first thing of the API, but for scalability, the second layer, which is I need to support 500 requests per second. And I need to make sure those requests come back in less than 5 milliseconds. So with having those things in place, and by creating an API, you can start moving on helping on what you want to do here. So one of the benefits is you get applied documentation, you get a standard of interfacing the data, exchanging between yourself internally, and you create an environment where your code is testable. Now, I suspect most people work in an Agile environment now. I started doing Agile development in 1999 with Extreme Programming, XP, and we were zealots. We would do pair programming, we would do short iterations, we'd do stand-up meetings, we did the whole thing. Ken Beck only wrote the book the year before, and we were doing this more than 10 years ago. And one of the principles of Agile development, which most people still lack to doing well now, is writing fully testable code, or writing test cases for the code. And I advocate a middle-of-the-road approach. You should take the principles of Agile and write code that's testable. That might not mean you don't test everything, but when you have a problem, you can test something. So it's important that maybe you mightn't be writing test cases to go, these are all the boundary conditions, But over time, you have a mindset so that if you need to do that, you have a system in place, and that will help you later when you want to start doing particular stress testing or really scalable issues. So it's really necessary to be able to create something which enables you to scale. One thing an API gives you, which people don't realize, is it gives you technology independence. You might think that's a little strange, but it moves to being a dependence on your specification, which is your API. And as I mentioned before, it's like testable. The benefit of technology independence is now, as long as you support the requirements of what was passed in and what was passed out, you support the load that's required and documented, who cares where the data is stored? Is it stored in MySQL? Is it stored in MongoDB? Is it stored in the cloud? Is it stored in a data warehouse? As long as you're satisfying the requirements, then all of a sudden you move to a point when you can interchange your components both in front of the API and behind the API. You could have some parts of your application written in Java and some parts written in PHP. As long as they communicate through the API, then all of a sudden you're not bound to one technology. People sort of go, I don't want to be limited to one technology, but I don't want to write my code being abstract because then it's not going to scale. We had this discussion today about someone wanting to port like Joomla to Oracle. And they're going, we don't want to make an abstract layer because then you leave out all of the business specifics or the benefits of the product that you have in place. But if you can take away that limitation of the technology, then you've been giving yourself power to be able to change things. And it's actually quite interesting when you sit down, and I've talked about this in presentations for an hour, particularly GoDaddy is a good example that I have tech days, where we talk about like changing the paradigm of how you program to think about what's important. And this gives you the ability to be able to scale. And I'll leave you with one principle that people generally don't understand about testing. Testing is not about testing your software to see if it works. It's about breaking your software because you want to know it does break or it doesn't break. That means testing a machine until it crashes. And that's necessary in your environment when you're going to have preemptive analysis, necessary when you want to deploy a new feature, necessary when you want to know the monitoring levels that you want to set on your server so you know what's okay. The server can run at 75% CPU. That's fine because it never really goes above 80%. Even doesn't if you keep adding load. It doesn't. The CPU is not a bottleneck of the resource. It's, say, disk, for example. But you might not know that until you've tested your systems. So it's important that you can stress test environments. So if you have a automated seamless deployment that you can just deploy your software onto a new machine, be it whatever version, compare different versions of MySQL, monitoring is already integrated. You have some sort of level of API that you can roll up. API is a great thing for us that are administrators or DBAs or system architects is because, if the websites are performing well and it's a client problem because the CSS is bad or because they haven't parallelized their assets to download, then that's not really your problem. You can sort of say, well, I'm fully tuned because I know I can support what we require. Because you can test an API. API is very easy to test. Doesn't need human interaction. So it's an ideal environment for you to go, okay, how many things can I actually load up on my server? What can I actually run to work out what's going to happen when the system breaks? Because ultimately, scalability is not about trying to be reactive to problems and saying, I can't support any requests or the server's always down or time's slow. You want to be more proactive. So now we get into the fun part, which is, when you're writing code, what are the most important things that you want to do? And there's 2 points I want to talk about. The first is that there's different levels of data access. So what you have to understand is that data isn't just data in a database that you read and write to. Data can be read-write, it can be read, you can have no access to it, or it can actually be cached. So in application development, you need to be able to support environments or portions of data where maybe write access is not allowed at this point in time. Maybe only read access is allowed. You need to be able to have your application to be able to proactively turn off functionality. For example, a user could log in, but a new user can't sign up because you're doing maintenance on the user module. So data is available in read-only environment in a slave, for example, but you can't add a new user, and you could proactively turn that portion off on the system. That means that your website is still available. It just means it has restricted functionality for a period of time. If you have a sharded environment, it might be that some portion of data is unavailable for each period of time. So it's important to consider this, and it's important to consider what is the system going to do when you have no access to data. what does your website look like when your database is down? You know, can you actually still operate your website without a database? And I have a really good example for that. You know, and one of the things that's important here is that, you know, can caching help you or not help you? So let me give you an example. I came into a client, I sat in at the meeting in the morning, getting an understanding of what's going on. This is actually NBC Universal, so we're talking a large organization. And so the development team was saying, we need a maintenance window to do software upgrades in the software because we just can't handle performance. In this case, it was like Heroes TV show and all these other TV shows were happening, and they wanted to be able to like do changes. And being a good manager, the CTO said, no downtime. You know, and then the development team was starting to plead, you know, we need to be able to fix this. We know we can't make improvements unless we improve the performance. CEO says no downtime. So at this point in time, after being sort of like, okay, I've been here for 5 minutes, I turned around and I asked him the question, what is your definition of no downtime? Because if you have some perceived idea that you need to do something and the server can't be down, then what does that actually mean to the business? So in this particular case, I'll actually give you his answer in a minute. In this particular case, the CTO, in very concise terms, said, I want to be able to serve ads and I want to be able to serve content. Didn't say anything else. He didn't say that I wanted to be able to upload new content. He didn't be able to say that users wanted to add comments. He didn't want to say that he wanted to sell merchandise. He just wanted to serve ads and serve content. So when you think about it, can you do that on your site without access to the database? So you can. If your ability for accounting is unavailable on a read-write server because you're altering a table, then get access to slave to read the data. Or can you cache content so that, you know, if you can't serve up the page, you can serve a cached version of a page that might not be personalized. So these concepts are important because as a DBA in a MySQL environment, which is less friendly for things like maintenance, you need to be able to support things like downtime, doing software upgrades. If you want to reduce the load on the system, be able to proactively turn things on and off, or to support part functionality of the system. I mentioned dark mode before. I wasn't going to bring it up, but I don't know who's seen it, but if Twitter comes under load, they start turning off, and not just Twitter, but they're public about it, and you can I can give you references to examples. They start turning off high impactful functionality, not necessarily high volume functionality, but functionality that takes a lot of resources. They start proactively turning it off. And one of them is search people. So sometimes you can't actually search for purposes, it's temporarily unavailable. So they've restricted the functionality on the server to remove something which is a very resource intensive task to overcome some particular load problem or to be able to support some level of upgrade. Another one of those techniques of being proactive and working what you want to do. So I can't tell you how to do all this because it depends on your application. What it is a little bit of a mindset of being able to understand how you present data to the user, how you ask the right questions, and not just come up to a brick wall and saying, okay, one need access to the database all the time. You need to be able to probe a little bit bigger because part of the problem is perception. So, if you can meet the needs of the business and you can provide the availability that's available, then it gives you room to grow. And this is very important when you want to start scaling systems. Everyone still awake? Yes? No? Okay. So we've just started talking about the application. We've talked about, we want to make sure it's an API because that's really going to help us moving forward. We want to consider the concepts of don't just think of the data as one database view. There's different levels of access to the data. You also need to consider different ways of scalability, the different principles involved. And the first three to consider are read scalability, write scalability, and caching. So the most common way in which people do this in MySQL is for read scalability, they just add slaves. If you have a slave environment, you sort of add a slave and it's load balanced, and you can work with that. Write scalability, the general principle is sharding, which is an application level process. It's not a database specific thing. You have to write code to be able to shard. Or you have to architect your environment so that you can shard. And caching is generally the domain of something like memcache. So that's a start of what you want to work with. But really, a complex environment is much more complicated than that. You have access to historical data, for example, or data from a data warehouse that's moved from ILTP to BI. And as long as you have that API level in place, this gives you flexibility to be able to have that data in different things. We were talking earlier about InfoBright. There may be particular operations that work well on your ILTP system, but you want statistics that are available and they need to come from a different system, but the data is populated on a daily basis, something like that. As long as the interface is consistent, who cares what the data is, as long as you satisfy the requirements of giving the right answer. So read scalability, as I said, is generally the domain of replication. Replication is very limited in terms of the weakest link of replication, which is the replaying of the slave, which generally means that limits your production write throughput. And then you have to consider, how do I make a system more scalable in a write mode? And that involves the concept of starting off with partitioning what's happening on your system, identifying what data is going where, what's going to the binary log, and being able to split those things out, and then also architect how you would write your application to retrieve information. If you have a query in a page that's doing a join across 3 tables, and now those 2 tables you want to split apart and put into a different system, you can't do that because you have to change the code. But if it's an API, then all of a sudden now you have an ability to encapsulate something that's taken away from the actual front-end layer. So good examples. People think about I need to be able to scale my system. How do I write scalability? On certain systems, that is so simple, is because you look at the access path to the queries of data that you're looking at. And in a lot of systems, there is a very simple chunk that can take 25% or 50% of the traffic away. One is people who log stuff to the database. Log every click, or log this, or do that. You can put that on a different server because you're not using that logging information to actually give feedback to the user. So I've seen environments where I can say, well, create a separate server, put the logging over there, and put the data over here. Now your system is only doing 50% of the throughput. It's doing less logging to the disk for binary logging. Replication can now keep up, and your logging goes over a different system. It can be stored differently. It doesn't have to be in a database. It doesn't have to be in a replication environment. You may have it where you just snapshot it every few hours. Some things like that are very easy. It's a very simple partitioning system to break it up. When you start moving to having to scale your system, scaling the system comes down to being able to look at components of your system, and the biggest issue with that is joins, where people join a lot of data together. So write scalability is an impossible thing to just do in an agnostic way. It actually requires you, with MySQL, to actually know how to pull apart your application. And this is why there are actually some products out there now that are professing that they use their MySQL storage engine, and they'll just do that for you. They'll do the automatic sharding, and they'll put data elsewhere. And it takes away the need for the code to change to do this. And if you build your code on popular products, open source products, even in the recent years, a lot of them weren't even using read slaves for replication. They were still writing for the master, and you had to do some custom thing to split things over, and it was just messy. So write scalability is really a domain that there is no one answer for it. There are some very simple things that you can do to partition things. Caching is something that people overlook a lot. And it's really important that caching isn't just caching what comes out of the database. Some systems, you can cache data with MySQL by default with the query cache, and that's great. And if you if you can do that, it's a quick win, but there's a penalty for doing that. If you can cache data in your application layer to a point where you can actually write code, like a chunk of HTML code that can be cached, then that's not actually a database problem, it's an application problem. So caching actually, I have it here as a point, but there's actually 3 levels of caching, initial levels that you want to focus with. And these things are of huge benefit to the database because you have to identify what's causing all the access to the data. And then because it's all about reducing the load on the database server so that you can support more load. And that comes down to removing redundant, and some of my other slides from my related talk to this really goes through into certain problems like how to identify particular bad queries, how do I work with them in terms of being able to cache data. And maybe we could drill into some of those if we have a little more time. Yes, Mike. If you guys are awake and you want to ask questions, then yeah, I'm happy to answer. So are there any questions? Are there any questions that are not related to MySQL?
He wants us to chat while he changes the tape. There are people who are busy.
Yes, I can take care of that. There are no questions. So people just came out to look at me. Wow, they didn't even come to hear. Yes, fire away.
Cache.
Cache.
You going to talk a little bit about write-through cache or lazy cache, or what do you see as...
I wasn't really going to spend too much time. The question was, am I going to talk a little bit more about caching?
That affects your API.
Yes. So actually, let me give you a few examples of caching, and we can talk about the question which would turn like write through or write back cache. I'll give you a good example of there are different levels of caching, and where people work with database. So we'll start with MySQL. MySQL has a query cache, which will cache data in the system and will make queries that are run repetitively almost instantaneous. Huge performance benefits. However, it's very coarse-grained. You make one change to any underlying data that's flushed. So a good example is with Thomson Reuters. They collect statistical data, ticker data on stocks from all around the world, and they have 30 years of data. And they stick it all in one database. And so when everyone's querying for the ticker data, they're looking at data between certain two time periods, one between like 1970 and today, or 1980 and today, or whatever like that. But 95% of the data is actually read-only from the previous 30 years. And they'd actually done some intelligence of actually putting the data in two tables. So they were halfway there, where they were querying one table of historical data and one table of common data. So I didn't have to convince them to do that. But I simply said, why don't you put the historical data on a different database instance and put your normal data on a normal instance? That first database instance is read-only. The data it's 30 years of data that's not going to change. Changes extremely rarely. And every query that's executed could have been stored in a cache, so they get instant performance improvements by using a database-level cache. That's an easy win. It's hard to do that because you have to have architected your system to support write-once data. If you can do that, then caching can really help you out. So we then move back a little bit further. The next level is, okay, I run a query frequently. I want to cache the results of that query, and I want to be able to put it into a cache. And that's just the results of the query. Or there are other ways where you go, I want to retrieve data about a particular user, but if I retrieve their users, I retrieve their photos, and retrieve their comments, and retrieve their friends, I sort of keep appending this to my cache of that user information. Or the other one, which I've done successfully for a Europe company, is, it's typical Web 2.0 media system where they have like videos and comments and users, and it was taking 600 milliseconds to load the front page of the server. When I left, it was taking 60 milliseconds because I eliminated the SQL statements that were happening on the system. And things like the most popular videos of the last hour. Well, you don't have to generate that for every connection. You don't have to generate it even for once a second. You could generate it like for 2 minutes and store the data in a file, and you've got automatic caching. The problem with caching, which comes back to the original question, is the validation of data, the synchronizing the data in the cache with what's in the database. And generally with caching, there are two principles. There's the concept of a write-through cache and then a write-back cache. There's different terminology used. But generally, if you're like writing data, do you write it to the cache first and then you write it to the database second? If you're reading data, do you read it from the cache? And if it's not in the cache, you read it from the database and then put it in the cache? And these principles are okay, but then what happens when data changes and it's in the cache? How do you invalidate the data that's in the cache? So again, a caching process, you may find that writing data to the cache first is more important because then you can continue doing work and that can be persisted in some other way. The invalidation thing is the most complicated stuff. And Facebook actually wrote patches to take what was in memcache, queries that would run, it would automatically go in either populate memcache or flush out memcache. There are like memcache user-defined functions, but it has to be written in the code. So it's important that you have caching. It's difficult to know how caching is going to work ideally, and there are lots of different nuances that you want to deal with. And I mean, even with caching, you think that's great. I have a memcache cluster of 10 servers, and then people go, oh, that's fine. Memcache is smart enough to allocate stuff. Actually, it's not. Quite often, memcache is only half utilized on servers. So you have to start doing the same things you do in a database in terms of scalability. How do I invalidate things? How do I rebalance data? How do I do that level of write scalability and partitioning? You had a second question?
Just real quick, there was another level too, which we used to consider caching. We don't talk about caching, which is just flattened out joins, which is denormalizing or normalizing data.
Yes.
So we have like tables, multiple tables, we duplicate the data, so we actually normalize it, and that becomes actually extremely fast because now you have one point. It's still in a database. It's not so much in memory, but that also.
Yeah. So I mean, I could spend an hour. The question was like about doing normalization or adding redundancy to the database. Effectively, what we're saying is we're taking a third normalized form of a schema, and people use the word like we're denormalizing it, but that's actually the wrong word to use. You're actually optimizing for access to the data. So you have a third normalized form, then you optimize for performance, and that may be having redundant data, duplicate data, which you may either like want to keep in sync or not want to keep in sync. I'll give you an interesting example. When you want to shard a system and you have, it's a system where you can send messages to other people, and there's myself and I have like 10 friends, and I like want to send a message out to my friends, but, your sharding is users are on individual servers. So, okay, I'm writing a message, then, where do I put the subject line and the details? Is it on my server in the shard environment, or is it on the server or the person who received the mail? Because now the servers are separate, so you can't do an SQL statement to join against the data. You have to do two queries. In this case, you may find that you store a copy of the subject line on your application because I'm sending the message because I want to see that, and then on the destination you saw the subject line and the actual body of the message. And then if once you send something, you're probably not going to look at the body as often as the recipient, but you can always retrieve it from the recipient. In this case, you would duplicate that data. And you may think, okay, well, that's not a good design practice, but it actually streamlines performance quite well. Maybe I lost a few people on the example, but it's something that's important to work with.
You mentioned a couple of products that do automatic sharding. Which ones are those?
Okay. Let's start with like MySQL. MySQL has MySQL Cluster, for example, which will automatically balance data for you across multiple nodes, and it's synchronous. But it's in memory, and it's restricted to doing few joins, and it has great throughput. Well, they're different products, but from a MySQL perspective, there's a few storage engines that are like working this now. There's one that's been around for a few years that's still sort of like stealthy called Clustrix. The Akiban Technologies out of Boston are working on doing that. There's a couple of layers in between. New York Times has a thing called DB Shards, I think it's DB Shards, where they try to actually do that. They create a layer in between, effectively mirroring the protocol. Yeah, it's sort of like a proxy, but it's actually sort of like they've duplicated the protocol themselves. Tungsten, Robert's not here, I don't think. Robert Hodges, who was on the list of coming, so we'll give him a hard time. Yes. So Tungsten Replicator is another example of being able to have opportunities to be able to separate your data out into multiple environments. But I don't think there's a simple solution just to be able to go, we eliminate sharding. That's really what you want. There isn't one product right now that does that. Drizzle, for example, is something that has sharding built into the protocol, so there's going to be support for that at a later time. But it's very much still the domain in a MySQL environment, which is low-cost commodity hardware, scale out, not scale up. That domain is at the level of application development. You don't really want to buy an Exadata machine that I saw today, a full rack, and it's like, that's really great, but how much does it cost? And people are saying it's like $2 or $3 million. And the other machine was like the one they're going to release, and it's got like 200 cores in it. That's great, but how many people can run that? So some things about just some pointers to think about. Read scalability and write scalability and caching and the concepts you have to think about. There's a couple of points that are fundamental to being able to determine how to do that. You need to look at your read-write ratio because, as I mentioned before, if your data is very, very orientated towards many reads and very few writes, then certain levels of caching will benefit you. This is the case of the YouTube phenomenon where one person writes a video and then 1,000 people look at it. So that's a very high read-write environment. If you have a mixed blended environment where you're doing a lot of reading and writing, then it's much harder to have the concept of caching and then being able to scale the reads and the writes. You need to look at your business needs, what's important to do certain things, and it's important to look at the rate of change of data. People think about creating a sharding environment when they start their system, but after users have been on the system for a year and they have 500 friends and 2,000 messages and thousands of photos, did you actually architect your system right when you first started when users have no data? So queries change over time because the change of data, the rate of change of data, or the volume metrics of data changes, and you need to be able to support those. The issue with scalability is you can't create the next Facebook now unless you have lots of money, because scalability is an ongoing process. Twitter is a classic example where they didn't follow the 6-point plan, and they had stacks of problems early days where they had a single database server and it was crashing, and they didn't know what was going on in the systems, and everyone was complaining. The approach of doing this is something that you've got to continually do all the time. So you might put something in place now that does scalability, but next year you have to adjust that because the volume of data or your usage patterns have changed. So it's a complicated thing to do. It's not something that you can just do and leave behind. And there are very few environments that just lend themselves to being able to be sharded or partitioned or scalability really easily. Most of them are more complicated. Ironically, one of the high volume environments is actually really simple to do this, and that's the gaming. The gaming industry, where really you're one user and you have a finite amount of data, over your console game or something like that. That's pretty easy to actually shard and scale because you're isolated. Unless you're interacting with a lot of other players and playing multiplayer sort of stuff, it's actually very easy to partition that. In our Web 2.0 world where we have friends and comments and friends of friends and all these sort of things, it becomes much harder to actually break things up. Whoever's ever looked at the Facebook API? In the Facebook API, you can't do joins. The reason why you can't do joins is because when they architected it, they didn't quite architect their write scalability very well because they did it per network, and that was not ideal. But they wrote their queries so that you can't actually query everything and join together. It's actually broken up, which allowed them to actually scale in a write mode much more easily. But their failure was that they would actually clump data together by network. So it was okay when they had like 5 colleges, but then all of a sudden, open up to the world, and some networks are 100 times the size of other networks. So they had half of their sharding, partitioning approach work, and the other half they had to adjust. Went too far there. I want to talk about 2 points. I actually have them listed later, but 2 issues with scalability, and I actually have a whole paper I'm writing about this, which is consistency. You have to accept that consistency may be something you may have to relax. But what does that actually mean? Does that mean that your data now is not consistent between the master and the slave, or between one server and another server? What's important is that for all of these principles of scalability, you have to know really what you need to have. And I have a really good example with consistency that I educate people on. And it was a question that I was asked in a job interview several years ago, and they said, on the Dig website, how do they keep making sure the counters are up to date? I click I like this. There must be thousands of people that are doing that. How do they keep that? How do they support all those transactions together to make sure that the number gets incremented? And I said, you make the assumption that everyone sees the same number. The view of consistency is a user perspective view, not a database perspective view. People think of consistency of data stored in the database, but if you as a user said, I like this, and the counter went up, would you be happy? Yes, you would. You don't run 2 screens side by side to actually compare that. So consistency, a little bit we talked about before about understanding what the business needs are, or looking about perception. I could spend a whole hour talking about how you can work with consistency. This is consistency and data interoperability are the 2 things that you need to worry about when you're looking at read scalability and write scalability and caching. How do you manage these things together? Data interoperability is data may be in one source, another source may be in the cache, maybe in the database. How do you architect your system to make sure that's right? And one principle is actually to create an environment where you do write once data. And that means that the data becomes sequential. And it's a little bit difficult to explain in a simple example, but if you have environments where you might continually update one particular thing of one item, and 90% of the data never changes, then taking that one column or that one item out and denormalizing it turns your environment into that data being read-only and a smaller portion of data changing. So therefore, all of a sudden, some data that couldn't be cached can now be cached. So there are lots of tricks, but each one really comes down to looking at your particular application and what you can do. So really the goals here, when we start talking about different principles towards scalability, is we need to be able to support the growth of the environment you want to do. I've talked a lot more about lots of things, but when we're starting about like removing human input, that's very important, and it's very important that it's ongoing. What this does is that the availability options of your data, being read, write, cache, whatever, and the different scalability options between how you do scalability between write scalability and read scalability and caching, gives you the footprint for a scalable data store. And I say data store because there's no longer just databases. There's relational databases, there's non-relational databases, there's key value stores, there's schemaless stores. They're all to store your data. So you need to start, again, thinking about other things that do that. What I've shared with you today is not rocket science. You don't need to be an expert in math to understand it. They're principles that you can apply to everything that you're doing in place. And whilst I have another talk, which was sort of the original one, which sort of said, okay, my database is slow, how do I make it faster? Or, I'm executing 2,000 queries per second with 20 users, what's happening? That's a problem and there's a solution, and it's very easy to go through those scenarios. But to actually walk away and go, how can I apply what I've heard tonight to actually make your system more scalable is, I feel, of greater benefit. So just to recap, because my hour's up, I only had an hour. Don't push me. I could do my next talk for another hour if you like. So what I've talked about tonight is principles to apply. It's not going to solve your scalability needs, but it's going to be what's needed to be able to achieve success. If I want to talk about some more things that become important, there's a list that I have here, like, reducing the deployment time. I like it when I talk to my friend at Facebook and they go, yeah, we can deploy 25,000 web servers in 40 minutes. And I go, that's pretty good. But we keep trying to make it faster. So, deploy a software package that fast is pretty good. Identifying the right metrics that are important to the business, not just to you, because at the end of the day, it doesn't matter whether your system is performing good or not. If you're not getting the right number of orders per hour, then that's important. We haven't really talked about people, but team dynamics, looking at risk, continual improvement. I mentioned data interoperability, which sort of comes into three areas. I touched on write once data. I touched on consistency. And the other thing that really you have to be important is you have to consider the asynchronous nature of things that you're doing. Any data that you can defer from synchronous, which is I wait for a response, to asynchronous, means that you can put it into a queue. It means that you can scale the way in which you process that queue. Again, it's a different paradigm shift. So, a few things. I'm very big on making sure that people monitor their systems. What happened, what's happening now, and what's going to happen in the future. And you can't predict the near future, but maybe you can preempt it, and that's actually quite good for scaling. Never run your systems at 100%, because that's an insurance policy. Ask this question to the management. How important is your data? What happens if the system's not available? And if they say, well, that's not acceptable, you say, well, I need more resources. I need hardware to do disaster recovery plan. I need developers to stop deploying code without going through testing. What's important to the business. I talked about the 3 levels of data access and 3 levels of scalability. It's important to think of those things separately. And once you start doing that, it changes the way in which maybe you might deploy something. It can really help you in terms of being able to do incremental releases of software, to be able to have rolling upgrades of software, to be able to have like master and slave or a master and failover master, to do almost like seamless data changes, data schema changes, by having particular environments to do that. And most importantly, if you can't drive a keyboard, if you need a mouse, then you should find someone who knows how to do things on the command line. Because scalability is all about automation, and if you click and point, you can't automate that. I see plenty of people who are database administrators, and I just cringe because it takes them 3 minutes to log into the system. And I go, okay, how many systems are you logging into? Oh, we have that particular environment, we have 12 systems. Well, how's replication slave running across the 10 systems? They've got to log into 12 systems with a key fob. And, I just go, okay, well, if you go over there to the jump box that you have and you run the script that I wrote for you, then you can do it distributed without even logging in. What I didn't talk about tonight, which hopefully people weren't upset about, was when I was originally contacted, this was the paper that I had submitted, and then I decided that I didn't really quite like the terms of it. But it's related talk, and I talk about what are the most common mistakes and how to avoid them. And a lot of what I've talked about tonight are portions of how to address certain mistakes. But just to give you the feedback on some of the points, I run through, it's actually 9 points that I run through. It's like, my website's slow, or why is my database so big, and I can't access my website. It's crashed. Yeah, do you have a backup and recovery? There's some very good points there, and if people want to stick around, I can quickly run through some of those slides and give you a couple of examples. A really good point is that people complain the database is slow, and it was actually, I think it was a discussion before we started. I've gone to clients where they say the database is slow, and I look at how long it takes to create the HTML page, and it was 400 milliseconds. And it was taking 5 seconds to load the page. And I said, sure, I can tune your database, but you're only going to let me tune 8% of the actual problem. 400 milliseconds to 5,000 milliseconds. So it's important that you know where the problem actually is. And that's where it's important with the instrumentation, because you can look at something in totality, but you need instrumentation at the application level to break down certain things. And there's some good points. I have some classic examples of database SQL, capturing and analyzing SQL. The most common problem that I find with clients is people run the same SQL statement more than once. And if your system's getting overloaded because it's running too many queries, generally the easiest way to actually tune a system is not actually tune SQL queries, it's to eliminate queries. The best way to tune a query is to eliminate it. And quite often that's actually very easy to do, even if it's like 5% of traffic or 10% of traffic, or in some cases 80% of traffic. So there are some points there. I don't want to bore you with those things. I'm actually giving that in 2 weeks' time. These slides and those slides and all my other talks are online at my website, which ironically is my name. And yes, it is a little bit long for Twitter, but that's life. And I did want to wrap up by saying that the ecosystem is changing with regards to MySQL, and one of those things that benefits you, the community, is there are a lot more conferences. On Sunday, there is MySQL Sunday, which is 4 tracks of 4 sessions. Huge numbers of people have already registered. I think you can still register online. We have 2 more tickets to give away in the raffle with regards to that. And next year, there's not 1 conference, but at least 3 already. The original MySQL 1 and 2 Oracle-related contents, both which have dedicated MySQL content, multiple tracks. So, and there's a link. I wrote a blog post recently about them, so it's there for you as well. So you can pull it off my slides when I upload them, hopefully tonight, or you can come and get hold of me. And that's it. So if there are any questions, fire away. You only have to wait another 35 minutes before you can leave. Wow, this has been the quietest crowd that I've had for a long time. Aaron has a question.
So I have a question. When you talk about APIs,
yes.
I work with 2 different kinds of data stores, right, and MySQL.
Yes.
But not all SQL functions work in input, right? So I have a subset.
Yes.
So I have to write certain types of queries for each one, but you said 1 API.
Yes, you would have 1 call. The question is like, okay, if the data source that stores the data, for example, current data and historical data, one stored in your database and the other stored in InfoBright, and it looks like MySQL and it smells like MySQL, but you may have optimized the queries or certain functions aren't available. How do I support that? Well, if you'd written the query in code, then you'd have to okay, I've got to change the code and I've got to break that out to if statements. You still have to do that inside the API, but to the person making the request, they still make the same request. They go, give me my account information from 2000 to 2010, and maybe 2000 to 2005 data comes from InfoBright, and the query is slightly different, and maybe the rest comes from the system. But the API is encapsulating those things. The user doesn't have, when I say user, I'm talking about the client application. Maybe that's the web's, the developer, who's writing code, doesn't need to know about doing those things. And I didn't mention it, but another reason for having an API is that for administrators, you have greater control over the code because you can test the code in isolation. Most people who have problems on larger systems, and I have a friend who's a DBA, we do this on a top 10, top 20 website, and he would get paged at 3 a.m. in the morning, and people go, oh, the system's not performing. And after a while, he woke up and said, did you roll out any code changes? And they said, oh, yeah, we rolled out a new version of software. He said, well, roll it back because you wrote bad code. And it happened week after week after week, and they still wouldn't learn it. But if you have it into an API, then you have a better level of encapsulation, particularly be able to test things or to go through a verification process or to be able to run certain things in isolation without, involving the client side of things. And hopefully you'll have more control over QA of those queries, optimizing those queries. It seems like it's more work, but it's actually less work in the longer run. And quite often it's a little bit like quality, software quality. People don't realize that quality is important. It's too hard to add that level, when we start doing coding. But if you've worked on a project where you've had 30 people for 2 years work on it and you didn't put it in place, then all of a sudden things are far more expensive to change. And in our fast-paced environment, it's still the case. It's just much more condensed. Fire away.
Since we got time, but
Absolutely.
In general, application programming should never be looking at tables, should never be looking at rows. They should be looking at the concept, should be looking at the data.
Should be looking at the business. Yeah, you're not looking at...
So data access objects, whatever you want to choose to use, API, whatever you want to call it, it's just the right practice anyway. So totally
Sure.
agree. Since we talk about that, you want to talk about ORM?
Okay. ORM, object relational mapping, or better words to use, something a developer uses because they don't know how to access the database, or a Java zealot would say, data in a database, that's just a persistent store. I don't care. ORMs like Ruby on Rails and Hibernate and iBatis and these sort of things are not friends of databases. Okay? And the reason why is because database people didn't write them. When structs first came out, like pre-version 1.0, like this is in the late 90s when we were doing Java stuff, I looked at that and I went, this is just awful. I would never let this run against a database. So we went like, oh, we'll throw that away and write our own layer. People now love Ruby on Rails and ORM and things like that. They are not friends to databases because they talk in terms of an object. And that object is, I want to get the user. So I have to get the user and join with the user address table, to join with the user's friends table, which joins with the user comments table, and to pull back all the data because they want to populate the whole object. And the reason why they do that is because they don't understand the concept of lazy initialization, where you only want to put on the screen the name and the email and their current address, but the ORM, because the software is sort of going, I'll just get the user object, it has to do all these things under the layer, under the scenes. And unless it's written correctly, just like lazy instantiate things, doesn't work. And people are shaking their heads because people go, oh, we use Ruby on Rails. And I go, well, that's half your problem. That's because you do select star. And that's what it does. But if you don't need those two text columns of the description of someone or the photo that they've added into the database, which has to be retrieved every time, which pollutes the memory that you have used for MySQL, which doesn't fit into memory, so it has to be written to disk. They're just simple performance problems. I could pull up some slides and...
Nobody has threatened your life so far?
What's that?
Nobody has threatened your life?
No.
So far?
No.
It's wonderful that somebody's actually saying that.
Well, I prefer to work more in terms of helping people architect their systems to be scalable, and there's a right way to do it, and there's the short path and there's the long path. And most clients that I have approach me because they have one particular problem or a performance problem, or the website is slow, and I go, okay, I won't show that slide. And I come in, and it's like an iceberg. It's the tip of the iceberg. It's the 10% that's above the water, and I address the 10%, but then I say, it's the tip of the iceberg. There's 90% below the water, and they're the problems that you have. And ORM is one of those things that sits below the water. It's not there, but it can actually cause a lot of problems. People use Ruby on Rails because it's very fast to develop. That's great, but does it scale? Well, that's a debatable story. And it can scale if you architect your system correctly. And one of the benefits of architecting Ruby on Rails is to not normalize your data, because then it doesn't create all these joins. That being said, one of the best projects that I've seen now, sort of like in the space of MySQL, is Akiban. They're out of Boston. And they actually thrive on SQL complexity. The goal of DBAs and architects and consultants is to simplify SQL to make it more efficient. And their system is actually designed, we want the queries to be complex because we're changing the way in which we store the queries, store the data, and execute the queries. So you don't have to worry about simplifying your queries. And they have a lot of promising potential there in that area. And that would be really good because they actually also integrate into the ORM layers. So then they can be ORM friendly. Yes?
You seem to speak of instrumentation and monitoring as
Yes.
geographically different. Such as instrumentation is always on a client device that's watching externally, and the monitoring is internal to the server-side software. Is that true? Or?
No, not necessarily. So the question was, monitoring and instrumentation is one sort of more internal and the other one more external. Monitoring generally is a little bit more external because it's looking at the bigger picture. So it's looking effectively at a black box. I call this, stuff comes in, stuff goes out. How much is it, in bytes? How long is it going to take? And you're monitoring those sort of things, and you're joining those things up with physical resources or other things. Where instrumentation is more the ability of being able to, a combination of monitoring. So you might be doing more specific business metrics around like a certain operation, which can be end-to-end or could be certain portions of a particular thing. An example is you're loading a web page, and here, who knows how to use Firebug? Okay, wow, that's pretty cool. So you guys are actually like HTML programmers. You're not database people. But Firebug is a good example where if you look at a web page, the web page loads, and it's done, you see the whole web page and you see all the elements on the page. So monitoring might tell you how long it took to do the whole lot. Like the example I had of 5 seconds on dig. But what you really want to do is you want to look at how long it took to load each individual part. And Firebug breaks it up and it actually shows you that breakdown. So, it does monitoring, but it's instrumentation of smaller portions. And for example, if you were like calling a page, and in that page you were doing, I'm going to query this data, and I'm going to query this data, and I'm going to query this data, and you use something like a Drupal or a Joomla or a couple of the other products, they instrument inside the code so they can show you how long each query actually took. And that level of instrumentation generally requires some level of coding, where monitoring can actually sort of happen agnostically. It doesn't need for you to change your code. Instrumentation generally, you need to embed that into your code in some way to expose important information. So if I want to simplify it, one you don't have to change the code, the other one you have to change the code. Make sense? Some way. Yes? So the question was, what are some specific things that I would put on my dashboard? Let me show you. One of my presentations is that I've given earlier this year is called 10x Performance Improvements. And so let me quickly pull that up, and I can give you an exact example. Most of these things are online, so it's a matter of finding the right one. So this is a particular client. They had a couple of database servers and a couple of web servers, and serving up content. And look, you have to monitor your system. Sound like a broken record. So I create a custom dashboard. I have 3 levels of alerts, green, yellow, and red. And this was actually a nice version of the page. They had one master and 3 slaves, and we created a failover slave, and we had a monitoring system. So there ended up being 6 databases. There were 5 web servers, and on the dashboard for the database, I think it's probably the next page. Maybe not. I thought I had a description of them, but for the database, I was looking at the system. Was that up? I don't know if that was uptime. I think that was actually up. No, I think it was uptime of the server. 22 seconds was it? 22 seconds is the last time I got that particular thing. 0.133 was the ping time to the server. Sorry, I actually have, I think a different slide I have these described in more detail. And these numbers may when they're green, but you'd mouse over them, they give you the full information. You put a lot of information on one page. On the database, it was like how many database connections, how many idle database connections, how many active database connections, how many locked database connections, when did I last query that data, 4 seconds, 2 seconds, 5 seconds. The 0 is what is replication lag. Then on the website, we would do 3 different examples of web pages, and we would time how long they took to load via a wget. So in this case, 88 milliseconds, and the content was 84K in size. And the numbers on the end, 2, 3, and 0, were sort of tricky things, but basically that meant 2 queries from the master server and 3 queries from the slave server. It was instrumentation that we put into the HTML page. I don't know what the last number was. Then there was another page which was 152 milliseconds and 76K. It was a different path on the front page. And on the web servers, we would log times of when it was last monitored. I think the uptime's not actually there. Ping times. Actually, it says up there requests. So HTTP requests came out of HT status or the status, and how many current threads there were and things like that. So what was important was we could put this up on the page, and this was good. We did this first, and they would see unpredictable performance. What they had was queries. I can't really find the particular case. But what you could see is and the CEO was there going, what's going on? And I could just pull up the dashboard. We just had the dashboard, and we wouldn't even do any information. We just had that. And what would happen is something would lock a table because they were using MyISAM, and then all of a sudden the number of locked queries would go up, and all of a sudden it would show yellow, then it would show red, and then replication would go like 1 second behind and 2 seconds behind, and you could just see it light up like a dashboard, and then 5 seconds later it was gone. And I've had clients who people are complaining that replication is slow, but the monitoring, which samples every minute or every 5 minutes, always says that replication is fine. But what happens in the 60 seconds between when you do it at the top of the minute and the top of the next minute? Does it go out? Does it go in? And the dashboard looking at stuff every few seconds, it was just visual. I mean, you don't have to use it as a tool. It's not a tool that will solve your problem. It's a triage tool that will identify a problem much more quickly and much more easily. And things can change more rapidly. And it was very good. We used this. In this case, we changed 2 tables from MyISAM to NODB. We monitored how long locking was. We had these things. All the data was available, and we could graph it as well if we wanted to. And we could just you could just go, okay, the system sometimes would take 2 seconds to load a page, and we had the stats of those things. And then overnight, all of a sudden, 95% and 99% of locking went away, and pages were consistently loading at 600 milliseconds. And all of a sudden, the customer is happy because now at least it's consistent. So then at least they're giving perception. Then it's okay, now it's consistent. Let's actually improve it. And this is a good example. You can pull my slides down where we went from 600 milliseconds to 50 milliseconds, 10x performance improvement. That's not bad. And they're just they were simple things in terms of identifying the queries that you have to find, looking at particular problem queries, defining different types of indexes that you could use, storage engines, offloading master load. In this case, was an example where they were doing a logging, and we just ripped that apart, taking queries which are bad that you should really optimize, looking at storage engines, configuring IDB correctly, caching, and the best performance improvement is to actually eliminate the SQL statement. And there's a little thing about particular concepts of sharding. So you can see that I say the same sort of things. Here's an interesting point. I don't profess to be an expert on client work. However, I do know a little, and I generally offer this. And there are some very simple things that you can do to make your website faster. And some of them were reduce the amount of content in the HTML page. If there are all these spaces, and use tabs or don't use tabs. Or I've had a client that put http://domainname.com/blah/images in front of every image. Well, then you rip that out. The code is now the HTML page is 15% smaller in size. Just by definition, that's less data going down the network. So therefore, the socket time to open another web server is now less. Therefore, you can produce more load. different types of information with what's blocking, what's not blocking between JavaScript and CSS, and there's various rules. There's some very good examples of that. I was going to talk to you about it, but yeah, it's on there. There's a guy called Steve Saunders who has books called like like Scalable Websites or something like that. It's from Google, and he talks about things like different types of content and converting images. It's a little bit like eliminating SQL when you go select the data for one row and then select the same data for the next ID, the next ID, and the next ID. That's called row at a time processing, as opposed to a chunk. It's like select all the data from like 5 queries, from 5 IDs and bring it back in one go. You can do the same thing with images on a website. You can combine them together and suck them all down in one go, and it's much faster. Michael?
Just wanted to plug the October 5th event. All about that.
Yes. And there are plenty of examples. I don't have the list there, but there are 2 things. There's a Yahoo. On Yahoo, there's something like 42 points of improvement. And Steve Souders, I think it's Souders. I have another slide. So they're 2 best references. And just those things alone can change the way your website works. Again, it's all the art of perception. But an example is people will have 20 assets. Assets is like an image or something like that on their website. And they're all at www.domainname.com. If you split them and put them on 3 different subdomains, like I1, I2, and I3, you don't even have to change the way they're stored. You just internally create a CNAME in the DNS and your web server, and then you pick one of those, and all of a sudden your images will actually load 2 to 3 times faster. So little things like that. I could dig up plenty of other slides, but it's just an example of the dashboard. I think there's a newer talk where I actually break those down, but did that answer your question? So what's important to you as administrator? What was important for the web service to see how the load was, and then for the business, how long was the page taking to load, and then how big it was. And those metrics were all we needed to do to make an improvement and go, here's the percentage X improvement. We could get it all from that one page.
And did you write that dashboard?
Yes, that dashboard is actually...
available on your website?
No. One day it will be. I have to sort of refactor it. I sort of started it with some other client, but it just takes time. Someone wants to help support me to pay me to do it, then we can do that. Or someone wants to hey, that's really cool. Can we get 5 people together and work on it? Then, yeah, it's very simple. It's just shell scripts, and it just generates static HTML pages, and it's defining the metrics that you want. Yes. So the question was, how do data warehouses differ from OLTP systems? I'm not really an expert in the data warehouse space or the business intelligence space. However, it is important to realize OLTP, online transaction processing, is designed to be short and sweet and generally more writes than reads. And data warehousing is larger volumes of data which you aggregate and you crunch and you produce results. And as we move into a technology age where we're creating data so fast that, someone said like last year there was more data created in storage in 2009 than every year beforehand. And we're continuing to do that at an exponential rate. So the issue comes down to what do you do with the data? MySQL is not ideally suited to large volumes of data, depending on what you're doing with it. If it's like you're just loading data in, then that's cool. But if you want to change a 500 gigabyte table to add an index, then kiss 3 days goodbye. So there are dedicated products. InfoBright is one that we mentioned. CalPont InfoDB is another one. They're like dedicated solutions which look and smell like MySQL. They use the MySQL interface. They have interface at LampStack, but they're dedicated for data warehousing because they're column-orientated stores. And then there are other products out there. There's like Kickfire, which is a hardware one. You move to like Vertica. There are other commercial products which they move to this column-orientated process, which is very good for aggregation. But it comes down to what's in your data warehouse. Is it data that you just keep pumping in all the time, or is it data that you're replacing? What are the queries that you're doing on the data? And the biggest problem that I see with lots of clients is, even though they do that, once you put data into one database, it's important that you could aggregate it up. You can summarize it. The Thomson Reuters was a good example, 30 years of data. But they couldn't think about, okay, let's just take the min, max, average, high, low of each stock for a year because 90% of the queries wanted that stat for the year across 30 years, but they're always aggregating it every time. So it's important to realize that. Another trick in terms of data warehousing, and this is good for reporting. Again, it's the concept of turning your queries into write once queries or the data so that it's cacheable. It was a organization that was collecting stats for viruses and malware and all sorts of things, and their user interface was stats for today, stats for yesterday, stats for the last 7 days, stats for the last month. And every night they had to recalculate it because every night, last 7 days changed. And I said, well, what if your interface said today, yesterday, this week, this month, and then like last month? Because then all of a sudden the boundaries change so that each night they only have to calculate today's data and append it either to this week's or this month's, rather than recalculating the statistics for every single night. They would do all this data processing. So sometimes, that aggregation requires a business logic sort of go, okay, you've got to think about how you're querying the data and how can you reduce SQL statements. It's an art to it, like everything else. Yes? Yes. Okay, so the question was, do I use any other monitoring tools? Do I have internet access here? Can I use this orange one? Oh, it's another orange one. Okay. So the question was, what do you use for monitoring tools? Okay, this is what happens when MySQL crashes. When my machine crashes and I reboot it, I get 15 pages of Firefox. Yes, I'm going to Barbados next week, in case you're wondering why that... all right, I think I'm set now. No. I'm having something that I can't say on the microphone in public. Ask me afterwards. I don't want to say anything until ask me afterwards. It's a career-ending, life-ending situation that I will not repeat in an audible sense. I'm trying to load a website, and maybe I don't have connectivity.
Try the other one.
I can go to CNN. Okay. The question was, what sort of monitoring tools do you use or recommend? Which is a good question. And the answer is to go to monitoringmysql.com, which is actually my attempt to try and improve the monitoring system, which talks about, what type of monitoring information that you have in place and what do you really want to do and how is it extensible. And I'm sort of, it's a bit out of date, I haven't done it for a while, but these are the sorts of products that you can find that do monitoring. Cacti, Munin, Nagios are like popular ones here. There are ones that you can purchase. There are other sort of things that I keep adding to myself that I didn't put in there originally. So that's a good place to start. Does that answer your question? And then, there's types of products, but then what should you be monitoring at the operating system level and what should you be monitoring at MySQL? The thing to realize is that monitoring products don't monitor everything. And if they don't monitor everything, how do you check something 3 weeks ago that all of a sudden is a problem now? So monitoring products are very good at just graphing the 20 things that it thinks it's graphing and throws away the other 300 elements of data that can be available from MySQL. And one of my goals here is to try to change the approach of monitoring so that these systems sort of poll more of a server which has collected rather than sort of like querying a database to look at show variables that I want, it's sort of like querying a file that has all the variables because, your system is okay and then you're starting to get a problem. Is that a problem that's just started occurring? Is it a problem that's been occurring for a long time? Or is it a problem that's incrementally getting worse? And you go, oh, now I need to load like this new statistic in the database and monitor that, but you can't monitor that reactively over the past because you can't get information that's already gone. So one of the biggest failings of monitoring systems is you should capture all the information it can. Google like the principle of everything. Capture everything, analyze it, monitor it. That's impractical, but you should always capture it.
For plug for Pacona, they do the better cacti templates.
Yes. So Barron and other teams have. Actually, if we went back to my slides, which was here. Oops. This is actually a good one to sort of like, what do you want to do for performance improvements in 10 steps? The first thing you do is you want to have monitoring in place. And so if you don't have anything, install Cacti, install the MySQL Cacti templates, which is sponsored by Pacona. If you're lazy, you can install Monyog, which is a free trial but a commercial product. And like that's just the minimum you should do. And then you should have Nagios, which is alerting. And there are some Indigo and a few others that are now replacements to Nagios. And that's the minimum you should have in place. And I see people that have no monitoring in place, and I mean seriously, it's a 15-minute job. And it's better to have something than nothing. Yes.
What do you know about the memory storage engine?
A lot more than I'll profess to knowing.
What's your opinion of it? What are use cases?
Okay, so the memory storage engine in MySQL is a storage engine where the data is not persistent. It's only stored in memory. Some of the benefits are then it's quicker. Some disadvantages are it's table level locking, so you don't want to run queries that aren't indexed on them too well. It's bounded by two conditions, two variables, one called temp table size and one called max heap table size, and you have to work out the minimum of those. I think just for that query, for a memory table that's used as a memory table, it's max heap table size, but if the memory table is used as a temporary table, it's the minimum of those two values. The biggest problem with the configuration is that it's unbounded. You can only bound the amount of data in one memory table, not the amount of data in all memory tables. Memory tables, you by default use a B tree index use a hash tree index rather than a B tree index. So you need to be aware of that. But they can be very beneficial for data, except session management data, like a Drupal or something else, who puts session data into a blob. You can't put a blob or text field into a memory engine. So there's some of the features of memory. I should pull out my book, which talks about the memory storage engine. What are some limitations of it? What are some uses of it? The memory storage engine is fixed width. So therefore, if you say varchar 255 and you put 2 characters in it, on the disk it's 2 characters. It's actually 4 characters, 2 plus the length, and 5 if it's null or not null. But in memory, it's actually 255. If it's 255 UTF-8, in memory, it's 768 bytes, fixed. So they have fixed width records. There's no variable length things. So that can really blow out your memory quite quickly. Which was leading me to some other question that I've lost it. The other thing is that it doesn't store blobs. So that's an issue. So there is a replacement to the memory storage engine, the eBay storage engine, which is actually in Drizzle. It's not in the main code base, and it overcomes some of those issues, particularly with variable lengths. eBay. It's just an eBay memory engine. That was written while I was doing work at eBay by a very smart person at eBay. So they've done improvements. At eBay, they use the memory storage engine as a network traffic tier. So rather than sending down large volumes of data, like 20 or 30K of like cookies and persistent data or user stuff, they could cache it in a caching tier. So therefore, you only have to send a token to the client rather than sending the cookies. So they cut their bandwidth of network down. And they had like 60 or 80 servers that would do like 12,000 transactions a second, and hundreds of thousands of connections, or 100,000 of users per server, and all the data was stored in memory engines. So that's the biggest example that I've seen use of it. It has its purposes. Did that answer your question?
Yes.
Okay. Good stuff. Anyone ask something I can't answer?
How do you think about foreign keys?
Ooh. So the question was, what do you think about foreign key constraints? Interesting question. No, I say it's interesting because someone asked me that question last night over dinner. Being an Oracle person, Oracle director, asked me the exact same question. And I thought about it and I pondered it a little bit and I said, well, the bigger question is the concept of consistency. And I'm in the process of writing an article. Consistency is something which people use or misuse the term. So consistency is like at a transaction level, is it consistent? Is it sort of like, is the data consistent? Is a foreign key constraint not violated, for example? So foreign keys are good for data integrity. But then, the issues with foreign keys is that people are generally lazy with them and they do them as cascading. And I think that's poor design because you're relying on the database to delete data, where you should always make sure that you have your application do things properly. So I like foreign keys for a level of data integrity when it's warranted, but most people don't use them because the data that you're collecting, it's duplicated or it's redundant in some other area, so they're not enforcing good data integrity anyway. So it's a double-edged sword. InnoDB is the only storage engine that does it, so you're restricted with that. Definitely don't use cascade delete because then you can do things. And be very careful when you use foreign keys and decide to use the replace command. So who knows what the replace command does?
I don't allow foreign keys.
What does the replace command do? Okay, so people believe that the replace command inserts a row if it doesn't exist or updates it if it exists. That is not true. A replace command deletes the row regardless of whether it exists or not, and then inserts the row. So if you have triggers that are delete rows or you have foreign key constraints that do deletes, you can have all these weird things happen behind the scenes that you're not aware of. So it's a mixed blessing. You've got to temper it with what's the important needs of your data and, is it highly normalized or not highly normalized? You're using InnoDB and all those sorts of things. So the question that Aaron is asking, is it a huge performance hit? Well, it can be. Yeah, I think the performance hits are more in terms of the locking that it's holding transactions hold long to reply. I haven't really done any benchmarks to do it. I don't see many people that use it. I see people that use it on my ISM tables because create table syntax allows it. It just doesn't get implemented. I could tell you war stories till the end of time.
A lot of ERD software also the exports that it creates automatically adds foreign keys across the database.
Yeah, and foreign keys also can hurt you when you have to load data from a MySQL dump because you have to dump it in the right order of cascading and they don't do it, so they go, oh, guess what, just disable the keys. Well, doesn't it defeat the purpose of having foreign keys? So there is a case for foreign keys. It's not implemented well enough in MySQL to justify active use. Is that a right way to describe it? Okay, we've got plenty more time. I told you you had to stay 35 minutes. You've actually done it. That's great. But well, anyway, let's wrap up from a video perspective. Feel free to come and talk to me. Now, before we finish, we have a raffle going, and I'm assuming that we have these books here.
Yes.
So there are 4 books, a shirt, and 2 passes to MySQL Sunday.
Does everybody have a raffle ticket before? Good.
I guess the question is that we get people can they pick what they want rather than you giving away certain things?
No, we raffle off certain things.
Oh, okay. Because, the first person that wins can choose which book they like. Yeah.
We do. Pick one.
All right. Well, I'm here.
The first.
I'm here. No, I think that the best thing is because,
Okay.
to say you get the internals book but you know nothing about internals, you prefer something else. Now, I should say this in binary, but that's going to make people difficult to understand. 245 is the last 3 digits.